Hello everyone. So throughout the next couple of weeks, we're going to be using these two packets. One of them is going to be the multiple choice packet, so I'm going to label that since these aren't really labeled for you. One of them is going to be the multiple choice. And the other one is going to be this short answer packet right here. So I'm going to label that short answer. You can find these both on WITS under the Documents tab. They will be labeled in the folder Continuation of Learning. They'll be labeled Multiple Choice Packet and Short Answer Packet. We're going to be doing some problems from the Multiple Choice Packet and the Short Answer Packet, so make sure you have both in front of you right now. If you do not have a printer, that is totally fine. You can do all of this on a separate sheet of paper. Just make sure you save your work because we're going to be collecting it at the end of the week. All right, so for Thursday, March 19th, we assigned questions 1 through 4 in the multiple choice packet, and page 1, so that would be this page right here, as well as question 1, which is on the back of it. Page 2, question 1, so I'm looking at this question 1, but it's page 2, which we can't really see, but those two for homework. All right, so let's start with the multiple choice packet. Make sure you have your calculator with you. If you do not have your graphing calculator, or if it's out of batteries and you don't have any at home, you can download the Desmos app. I believe you can just Google graphing calculator and it will bring you to that. Okay, so multiple choice questions. We're going to answer these and then talk about the strategy behind them. So question 1 says the function g of x is defined as g of x equals, and I hope that you guys can see this. I'm going to try to zoom in here. Equals negative 2x squared plus 3x. The value of g of negative 3. Now notice, over here it said g of x. In parentheses, there was the x. Here now, in parentheses, it's a negative 3. So what we're going to do, what that means, it's a special notation that means x is equal to negative 3. And what we do with that is we just plug it in for x everywhere we see an x in that equation. Remember, this doesn't really matter. You could plug in g of negative 3, but we don't actually solve that part. We just solve the right side once we plug in negative 3. So I'll show you what that looks like. So g of negative 3 equals negative 2 times negative 3 squared plus 3 times negative 3. Remember, parentheses are very important, especially when you're squaring a negative. And then all I'm going to do is plug that into my calculator. So let's see, hopefully you can see all that. So you plug in negative 2 parentheses, negative 3. Make sure you're using that negative button, not the minus for these negatives. Squared is right here. Plus 3 parentheses times negative 3, and you hit enter, and that equals negative 27. Okay, your answer to that would be right here. The strategy that we want you to realize is this is a really popular notation, especially on Regents exams, that g of negative 3 really just means x equals negative 3. And can you see that? Not really. Sorry, I have a bit of an interesting setup here. My phone is attached to a candle, if you're wondering what that is. So it's not perfect, but better than nothing. Okay, question number 2. What is the solution to the equation 3/5 x plus 4/3 parentheses equals 1.4? My strategy for this one, when it's a multiple choice question and they actually give me the answer, you could solve this, of course, for x, but you can also just plug in each answer and see which one works, okay? So let's try that strategy. If you would prefer to solve, that's completely fine. Let's just make sure we all get the same answer. So this is kind of like what we're doing is we are checking our work. So plug in answers. It's like a check. Okay, so let's go ahead and do that. I'll start by seeing if 3.06, now it's 6 repeating, so it might not be perfect, but we're seeing if it's close or exactly 1.04 when we plug that in. Okay, our calculator can't plug in repeating decimals, but they can be pretty close. So I'm plugging in 3/5. I'm gonna do alpha y equals to get my fraction. I'm gonna do 3/5 parentheses 3.06. And if you wanted to, since it's repeating, put a bunch of sixes, that's completely fine, you don't have to. Plus alpha y equals, enter, 3/4. Close parentheses, hit enter, and that equals 2.28. So it's not even close. Oopsies, I did 3/4, not 4/3. Let's fix that. 4/3. Good work. So it's 2.6, not even close to the answer what it's supposed to be, which is 1.04. So that one's out. And then instead of doing all that again, you can just hit second enter, and it will copy what you have, and you can just then plug in a different number. So I'm gonna hit the delete button. Now I wish I didn't put in all those sixes. Delete, 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 delete. And then you can do second insert to put something else in there. So 0.4, delete out that last 6. Hit enter, 1.04. So there's my answer. 0.4 is my answer. If this was a test, I would check them all, but for interest of time, we're moving on. Number 3. Number 3 says the area of a rectangle. The area of a rectangle is represented by this parabola here, or this quadratic. Which expression can be used to express the area of the same rectangle? Okay, so what they did here, they took this quadratic, it's an x squared, and they factored it. So that's what we want you guys doing. Or if you want the way that I would do if it was like a strategy, you could plug this into your y1 and each one of these one at a time into y2 and see what matches. Because we're doing strategies here, I'm going to show you guys that way, and then we'll also show you how to factor it. You could also FOIL out all of these. So let's just figure out what the answer is, and then I'll show you why. So in my y1, so go to your y equals, I'm going to put in the original. 3x squared minus 10x minus 8. And then I'm going to put in each option. Now I can right away get rid of b, because I know since remember this is the AM method, but since there's a 3 in front, it's actually the trial and error. But it doesn't matter. When this number is negative, remember it has to multiply to that number. When that number is negative, your signs cannot both be positive. It has to be 1 plus 1 minus, so b's out. So let's go ahead and see what one we think it might be. I'm going to try to do this. Let's do this one. I'm trying to figure out which one it is in my head right now. I think it's A. Okay. Yes. Well, yep. Okay. Let's do A, because I want to just get right to the right answer here. We're cutting down on time. Okay, so A says 3x plus 2 and x minus 4. And I'm going to go into my table. If my y values all match up, can you see that? My y values all match up perfectly, the blue and the red there. So that means that this is an equivalent equation, these two, which means it's most likely my answer. None of these would be my answer since they're all so different. Again, if you were taking a test, you would want to check that, but let's just double check by foiling to make sure that we're right. So 3 times 3x, we're going to do the rainbows and smiley faces here. 3x times negative 4 is negative, oopsies, I was going to say that was wrong. 3x times x, we'll start with that. 3x squared, sorry about that. Then 3x times negative 4 is negative 12x. Then you do your 2 times x is plus 2x, and then your 2 times negative 4, negative 8. Then you go ahead and combine these like terms there, and you get 3x squared minus 10x minus 8, which is your answer. Okay? If you were to factor that, there's another way to do this. If you were to factor it, you would just do the trial and error method, or you could factor by grouping, but in interest of time, I'm moving on. So the strategy there would be plug in your y1 is the original. y2 is your option. check if they match. So look for a match. Okay. Hopefully you're all still with me here. Question number 4. Mark bought a new laptop for $1,250. He kept track of the value of the laptop over the next 3 years, as shown in the table below. And then they want to know which function can be used to determine the value of the laptop for X years after the purchase. Now I'm going to do this one the way that I want you to, since this was the unit we were in. Actually, I think it was the last day of work where you guys were writing exponential functions. This is a little... it's kind of different. This was actually going to be the lesson you learned on Monday, but you know enough about it so far. Hopefully you didn't forget to solve this problem. So first things first, what I want to look at is my Y values. My Y values are going down. So that means I'm multiplying. Remember, exponentials all multiply. And the way I know it's an exponential is those little X's in all my options here. There must be multiplying by a number less than 1. Okay, and remember, in an exponential, you want it to be, each equation to be in this format, where A is your y-intercept, and B is the factor you multiply your y's by. We call it a common ratio sometimes. It can be called some different things, but I'm going to call it the factor you multiply your y's by. Okay, since these are going down, the number has to be less than 1. So my B value, I'm going to look at all my B's right now. Here's 1, here's 1, here's 1. It's always the number attached to X. Since these two numbers are greater than 1, 1.2 is bigger than 1, right? Goodbye, goodbye. Because if I was multiplying by that, these numbers would be getting bigger, but they're going down. So it's one of these two options. Then your A, guys, is your y-intercept. That's when X is equal to 0, which I don't have here. So I need to find that point. I'm going to add it in. When X is 0, what is my Y value? It's obvious that I'm multiplying by 0.8, and you can check that in your calculator if you don't believe me, but because those are the only two options here. So to get from 1,000 to 800, you must multiply 1,000 times 0.8 to get there. So the way we go backwards, remember when we go this way, we multiply. When we go up, we divide. So I'm going to take 1,000 and divide it by this 0.8 number and see what my y-intercept would be. So 1,000 divided by 0.8 equals 1,250. Now, I actually already knew that because where did I see 1,250? Right here. That's how much he bought the laptop for. So that was what he bought after 0 years after purchase. We would consider that $1,250, okay? So now I look at my options down here. My A value needs to be my y-intercept, so it would be D. They tried to trick me with the 1,000 there, okay? So my strategy here would be process of elimination. So eliminate wrong answers. I'm going to show you another strategy. The other strategy, f of x means y equals, guys, right? Y equals. You have a button on your calculator that says y equals. You can plug this into your calculator and see if your table matches this. So I'm going to just plug in the right answer and just double check that. So 1,250, parentheses, 0.8, caret. Make sure you have the caret when you raise it to the x exponent there. And then go to second table. And I got to go down to match up these numbers. So I want to find where x is equal to 1, 2, and 3. So where it's 1, it's 1,000. Can you guys, hopefully you can see that. Where it's 2, it's 800, and 3 is 640. So that matches my table perfectly. So my answer is D. All right, moving on to our part 2 packet. This is the next part of the homework. Or I guess this is classwork / homework. There's no such thing as, they're not differentiated anymore. Okay, so this is our short answer packet. Mine is pink just because I had a cover. Yours should just, this is your first page of it if you have it printed. If you don't, guys, what I want you to do is take a separate sheet of paper, and I wish I had one handy so I could show you. Let's see. Take a separate sheet of paper. So I'm just going to show you what that would look like here. And just put on this. So write down what I would do first is, let's do the date. So 3 It is the 19th, I'm hoping, not the 20th. Yeah, it's the 19th. Okay, 319. Homework, and we'll do, so it's the multiple choice. If you have this printed, go ahead and skip. Multiple choice 1 through 4, and go ahead and tell me all your answers. 1, 2, 3, 4, with the strategy. So I do want you writing down those strategies, okay? So there should be 4 answers, like question 1 we got, I don't even remember anymore. Let's say it was A, B, C, and D. Okay, that's made up. And write down those strategies. And then this is the short answer. Page, what we can call this page 1. And then I'm asking you guys to do question 1, which is on page 2, which is unfortunate that those are the same number, but whatever. So page 1, what you can just do is tell me what each of these are. So I'm having you guys talk about what functions these are. This right here in a V-shaped, remember, if you can picture that, what type of function is it on our wall at school? The V-shaped function is absolute value. So you guys can just do page 1. This is, you could say absolute value. Can you still see me? No, you can't. Absolute value. You don't have to draw these, okay? But when we get to the question on the back here, where you're graphing this, just go ahead and draw yourself a table. X, Y, try to be as neat as possible if you could help us out here. And then we'll go ahead and graph that, okay? It does not have to be perfect. Of course, we're not expecting perfection, but if you could label it like this so that Ms. Beck and I know what we're looking at when you turn this in, that would be really helpful. All right, anyways, back to this. So we're looking at each type of these functions. You've now learned all of them, so we can now answer all of these. So when it's in a V-shaped, it's absolute value. Remember, when it starts at a specific point like this and goes on forever, that should be an arrow there, that was your square root function. That was y equals the square root of x. Okay, we learned that on Wednesday last week. When it's in an S shape like this, that's your cubed root function. So that would be y equals the cube root of x. Okay, square root, right? We can't square root a negative, so that's why it stops here, but you can cube root a negative, so that's why you have some negatives and some positives, okay? Moving on, this one's a little hard to see, but the line's right here. I'll use my highlighter. This is just a linear function, okay? It's just a line. So this is linear. Since it's vertical, we use the term vux, a vertical line, undefined slope, x equals. So it'd be like, the equation here would be x equals, I think that's 5. Okay? This next one is horizontal. So this is still a linear, it's still a line, but since it's horizontal, we use the abbreviation HOI. Horizontal line, 0 slope, y equals. Okay, this would be the equation y equals, I think that's -6. Can't really see that very well. All right, these were your favorite. These were the piecewise. Just kidding. I don't think they were anyone's favorite, but here it is. When you see pieces like this is your pieces of lines. So it's considered a piecewise function. Okay, down here is just your classic looking linear function. These we learned last Thursday, where it started really, really, really small and then it shot up like a rocket. So these were your exponentials. When you think of an exponential, we want you thinking of that coin problem we did in class, where the little boy started with a penny and then it multiplied to $10 million in 31 days. So this was an exponential. And you can see that growth right here when it starts small, 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 and then shoots right up. If this continued to go on, it would just bottom out here, okay? And then last but not least, this is our quadratic. Quadratics look like U's. Don't get them confused with absolute value, which look like V's. Okay, these are nice and rounded out. So quadratic. So that would be like a y is equal to x squared type of problem. Okay? All right. Which equations have a vertex? Okay, so that's your turning point, remember. So which equations have a turning point, or when you think about in another way, which equations are symmetrical? If I cut them in half at a specific point, they'd be the same side out, they'd be the same on one side as they are on the other. So let's look at the quadratic. The quadratic has a vertex. If I cut it right at that point, remember the axis of symmetry, if I sliced it down the middle there, that was not the middle, close enough. If I slice it down the middle, it'd be the same on the left as it is on the right, and that happens at my vertex, turning point. So that's a vertex, so the quadratic. And the other one that has a vertex is your absolute value, because here's the turning point right there. Okay, same kind of scenario there. So the quadratic and the, I'm abbreviating, but absolute value. All right. Remember the y value of the vertex is considered the min or the max, right? These are both minimum points because they're at the bottom of the function. If these were flipped over, they'd be your maximums. Okay. Then it says to, let's see, graph a function using your calculator. You must solve for y. So if I wanted to graph any of these using my calculator has a y equals button, right? So I'd have to solve them all for y before. So let's just practice that. We haven't done that in a while. So to get y by itself here, I would subtract 2x. And it would say y equals negative 2x plus 16. Okay, to solve for y here, there's two steps because I have to get rid of the negative 3x and the 2 attached to y. So I'm going to add 3x over. 2y equals 3x plus 14. And then you go ahead and divide by 2. Divide everything by 2 over there. And you get y is equal to 3 over 2x. That would be your slope. Plus 7. That would be your y-intercept. And for number 3, even this negative has to go away if I want to solve for y. So it's like a negative 1 attached to my y. I'll rewrite it so that you can see that. So you go ahead and just divide by negative 1. And you have y equals negative 2x minus 9. Okay. So there's page 1 done. We're almost done here. So this question, let me zoom out a little bit. Okay, this one, we're going to practice graphing. That's going to be a lot of what we do in these upcoming days. Put equation into y equals if it's not already. This one is, even though it says f of x, remember that really means y equals. Write down a table of values. So when you plug that guy in, we're writing down a table of values. We learned this the other day, especially for your exponential, and graph and label. Okay, what type of function is given below? Well, I just gave it away. But when x is in the exponent like that, okay, very different than this, 2x minus 7, that's a linear, okay, when it's like a big X. If it's in the exponent spot, it's an exponential. So just as a review, that's going to look like going small, 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 and up. And I know this is an exponential growth because the number touching x is greater than 1, so that's going to go up like this, not starting high and going down, okay? So I just go ahead and put this into my y equals. So go ahead and clear out what we had there. Put in 2, hit your caret button to the x. I'm going to need to paint my nails for you guys so you don't have to look at my gross nails. Oopsies. Tab out. They'll be painted tomorrow. Minus 7. Okay, so make sure yours looks just like mine and that you put your x in the exponent spot using the caret right here, okay? And then let's go to your table. Now, if you remember from class on Thursday, the rule was to graph a few decimals, okay? So I'm looking here. I have a couple decimals there at the top, and then the rest of those numbers I'm gonna graph. Now, some of them are way too big, so I won't be able to graph them. So you could even grab 3 decimals if you want. Well, I'm just gonna stick with our 2, because that's what I told you guys in class. So I'm writing down the points that I'm gonna graph. So some of these down here I'm not gonna get to. So -2, -1, 0, 1, 2, 3, and 4. It looks like those are my nice points, and I'll stick with just a regular scale here. You could also change your scale since I didn't give you one, but I'm gonna stick to our normal scale. Each box counts as 1. And then I have -6.75, -6.5, -6, -5. Hopefully I'm writing these down right. 1 and 9. Okay. Let's talk about the transformations real quick. Remember, the normal exponential doesn't touch this bottom line here, but what happened to this guy? This -7 on the outside, as we know, means it moved down 7. So I'm going to show you guys where that line is. It's going to now, this whole line that it can't touch is going to shift down. 1, 2, 3, 4, 5, 6, 7. So this line, you don't have to draw this, but I'm just going to show you. This is my new bottom line, since it's been shifted down 7, and we'll see that when we graph. So the point -2, -6.5 over 2, down 6.5. So here's where -6 is. It's a bit past that, almost touching -7, but remember, it never touches that point. Okay, -1, -6.5, down 0, or over 0, down 6, over 1, down 5, over 2, down 3, 1, 2, 3, over 3, up 1, see now it's starting to grow quite a bit, and over 4, up 9, 2, 4, 6, 8, 9. All right, so that does look like my exponential. Make sure when you go ahead and connect these points that you never touch this bottom line down here. Okay, go hover and don't touch. All right, so there's my beautiful exponential. I'm gonna label it. Oops, they didn't use y equals, they used f of x equals 2 to the x minus 7. Let's talk about domain and range. This is a bonus if you're watching the video. Miss May's giving extra work, of course. Okay, my domain from left to right is arrow to arrow, so it's all reals. We can show it like that, or -infinity to +infinity. Remember, domain is left to right. Range is how low did it go to how high. So you can write this 2 ways. Y is everything greater than this -7. Remember, it never touches. So Y is everything greater than -7 without saying greater than or equal to. Or you can say Y, oopsies, not that, -7 to infinity with a parenthesis, okay, if you do interval notation. All right, and our final last question. If g of x equals this, so they gave me f of x here. Did I zoom in too much? I can't zoom out anymore. Okay, they gave me f of x being this function. Now they're saying a new function, g of x, is this, and this is a linear. Remember, if it's just a regular x without an exponent there, it's linear. If g of x is that, determine if f of x is greater than g of x when x equals 4. Okay, so they want me to either graph this or figure out which one's bigger when x equals 4. I'm going to show you guys the quick way. So in your calculators, I want you plugging into y1. Oopsies, it was already there. Well, plug in your original there, so 2 to the x minus 7. And then plug in your g of x in y2. So it's just 1.5x minus 3. Okay, and then we're going to go to the table where x is equal to 4 and see which one's bigger. They're asking me, is f of x, which is my first equation, is it bigger than g of x? Is it greater than it? So let's see. I'm going to go to where x is 4. My blue, guys, you have to kind of keep track of these, but my blue was my f of x. That was my original. And my red, the second column here, is my g of x. So I have my x, I have my f of x in that first column, y1, and my g of x in the second column. I'm looking for where x is 4. F of x was 9. G of x was 3. Okay, so now I'm just going to plug these numbers in for f of x was 9. G of x was 3. Is 9 greater than 3? Yes. This is a perfect justification. Okay, you don't have to actually show any work there. You can just show what your calculator showed you, okay? All right, guys, thank you so much for watching today. You guys are doing awesome at home. I know that you're working hard, and we're so excited that math is starting today. So we're happy to be back with you. As always, email me with any questions that you have, okay? We'll talk to you soon.